Welcome to a lesson with Dr. Pal. Let's talk about how we can um, use completing the square in order to graph something like this. Now, this is the equation of an ellipse. Notice you have an x squared and a y squared, and then these guys right here are different, these coefficients, but they're both positive. They both share the same sign. That would make it an ellipse. Now, if they were different signs, then that would make it a hyperbola. And if it's the exact same coefficient, that would make it a circle. Then we have x's and y's and so forth. So let's talk about how we might do this. So there's various ways that you can go about completing the square. Right now, I'll just show this technique. Let's look at the x's. So you have 9 and negative 54. All right, let's just look at those two terms there and just think about that for a minute. So you have 9, negative 54, and let's just make a little diagram here. Synthetic division. So 9, take 1/2 of this guy, which is negative 27. And then we need to throw something in here. What we're going to do is we're going to take this divided by this and change its sign. So that would be a positive 3. Then take this and multiply it to that, which would be negative 81. And then drop it, negative 81. So what we end up getting here, we can actually read off the completed the square from this little diagram. We have 9, because what we do is we factor out 9 from the first two guys. That's in the remainder here. Factor 9 from the first two guys, so we get 9x minus 3, but then put a square on, and then just detach that, negative 81. We just completed the square with those two guys. Now go to the next one, 16y squared and 32y. Okay, and think about that. So we have a 16 and a 32, and think of a little diagram here. So we drop the 16, drop 1/2 of that, which is 16, divide and change the sign to negative 1. Negative 1 times 16 is negative 16. Drop the negative 16. All right, so we can read it off from there. It's plus 16. Then you factor the 16 out of those two, which make it an x plus 1 squared, and then subtract 16. We just replace the two y's, or the two, sorry, that's a y, excuse me. Right, we just replace the two y's, this y and that y, with this expression, two x's with this expression. And of course, we have negative 47 is equal to 0. All right. Now, after having those, we can go ahead and we can combine these constants and put them on the other side. So so adding them together here, we have 81 and 16. That would be 97. And 97 plus 40. Yeah, 97 plus 47 would be 144. And then continuing on, we have 9x minus 3 quantity squared plus 16y plus 1 squared. And then if we divide everything by 144, we end up getting x minus 3 squared over 16 plus y plus 1 squared over 9 is equal to 1. Now this looks like a nice form for actually graphing the an ellipse, where we think of this as being 4 squared and this as being 3 squared, or just thinking of kind of encapsulating this all in one like this, and then thinking of it like this. So we can think of it as a transformation of just of a circle, of the unit circle even. And the center here will be 3, negative 1. and we're going in the x direction, each way out 4. And in the y direction, you go out each way 3. And then what we'd have is we'd have our ellipse, our foci happen on the longer length. Okay, so there's 2 of them. And in order to compute this, it's like we take this length 4 and we can put it upright right there. We have 3 and 4, and then we just need to compute this c. So it's square root of 16 minus 9, which is 7. So the square root of 7. So c would be the square root of 7. So the foci would be 3 plus or minus the square root of 7, comma -3, comma -1. And we got the 2 foci, and we also got the graph of the ellipse. And we got it from this equation by completing the square. Now we used the technique of using synthetic division diagram. However, let's do this let's do this another way. Okay, so reminding ourselves what we had. Okay, so another way we could think about this, which is actually not too hard, we could put the 47 on the other side, and then just think about the groupings of the x's. You can factor a 9 out of the x's, 9x squared minus 6x, and we'll just kind of keep a big bracket here. And for the y, we have plus 16, then you have a bracket, then you have y squared. Okay, so you're factoring out 16, y squared plus 2y. So just factor out the leading coefficient there in each case. Now, what we do inside of the brackets is we make a replacement. This x squared minus 6x we can replace with x minus 3 squared. So you take 1/2 of -6, -3. So you make this replacement. Now, in making this replacement, what we've actually done is we've actually added 9 to what we had. So we have to subtract 9 out. That's because if you multiply this out, you have a plus x or plus 9 there, but you want to get rid of it. So you put a minus 9. And of course, you have a 9 here. Now over here, you have plus 16, and then you could think the same way. You take this bit and you make a replacement y plus just 1/2 that 2 to 1 squared. And in the process, you added an extra 1, so you want to subtract off of 1. And that's equal to 47. All right, then multiply this out. It actually turns out to be the same. You get the same result as we had before the other way, plus 16. Just depends on which technique you want to use, but really, they're not. I don't know that one's better than the other way. But adding it over to the other side, you get 144, and it turns out to be the same calculation. All right. Thanks for watching.